So let's compute the second partials of a function. Same function we've been looking at so far. X squared sine y plus x. So remember, the fxx, for example, is going to be a partial with respect to x of fx. And so this is then going to be a partial with respect to x. We've looked at the partial with respect to x of x squared sine y plus x. This is 2x sine y plus 1. And if I take a second partial with respect to x, then I'll get 2 sine y. Fxy, for example, is a partial with respect to y of fx. And in this case, that's a partial with respect to y of 2x sine y plus 1. And that's going to be holding x constant, so 2x times cosine y. Similarly, fyy is going to be a partial with respect to y of the partial with respect to y. So del f, or del f del y, then del f del y again. So this is a partial with respect to y of x squared cosine y, which in this case is negative x squared sine y. And finally, fyx, this will be take a derivative with respect to y first, then a partial with respect to x. So this will be del x of x squared cosine y, and we'll get back 2x cosine y. So something that I want you to notice is that these partials, the mixed partials, are actually the same. So fxy is 2x cosine y. Fyx is 2x cosine y. So mixed partials are the same, at least in this example. And I'll say that this is not like a special fluke of this example. Mixed partials fxy is always equal to fyx. That's the subject of the next slide.